Okay, welcome to Physics Module 12, Part 2. This is where we're going to look at lenses. So here is a picture of a converging lens. So as the horizontal light rays come, they're no longer reflected like mirrors, but they are refracted as they go through the glass. And when they come in horizontally, they're refracted at different angles as they come in. But you can see all of these light rays are refracted to a single point. So, of course, that point is the focal point. That's where they're going to be focused at. So we can use this knowledge horizontal through the focal point, or if we were to go from the focal point, back out horizontal as we do our ray tracing, just like we did in the mirrors. Okay, so here we have an object and we have a converging lens. And remember, on a lens, unlike the mirror, we have focal points on both sides. So we're going to start by going from the object horizontal to the lens. And then because it's not reflecting, but it's refracting, it has to go through the lens. So it's going to go through the lens and on the focal point of the other side. Now in the second one, we're going to draw a ray so that it changes direction at the center of the lens. It's going to go through the focal point on the first side. And then it's going to change directions at the lens. Unfortunately, I didn't draw my lens quite low enough. And it's going to come out horizontally. Perhaps I should have drawn this one a little bit longer. All right, and then the last one is going to go straight through the center. So where our axis is and our lens is, we're going to go just like before we were going straight through the radius. If we go straight through the center, it's actually not refracted at all. All right, we're going to pretend that that's pretty close. I was kind of off on my line there. And then we can see that they meet way down here. And so that's where we're going to draw the tip of our arrow. Now, on a mirror, we said we were extrapolating when we had to draw the lines on the other side of the mirror. In this case, we're not extrapolating because the light rays should go through the lens. It's not a mirror, they're not reflecting back, they're just refracting, they're bending as they go through the lens. So in this case, we did not extrapolate any of these lines. So this is a real image. We didn't have to do any extrapolating. So we have a real image here. And it's upside down or inverted. And it's magnified. It's definitely bigger. So that's our first example. This is, again, a converging lens. And we were a little bit outside the focal point, and it ended up being a real inverted magnified. So for a lens, if the image is on the opposite side than the object, that's how it's supposed to be. That's a real image because that's how the light rays are supposed to work. If we have to extrapolate, they'll end up coming on the same side, and then that would be a virtual image. If in a lens, if the object and the image end up on the same side, then it's virtual. So let's look at the diverging lens. Here, it's going to come in horizontally and it's going to spread out. They end up being refracted away from each other. So on a diverging lens, if all of these light rays come out and they diverge from each other, then we're going to have to extrapolate backwards, and you'll see these smaller lines are my extrapolated lines, and that's where we're going to get the converging. So let's look at how we're going to draw these, except I didn't put an arrow in here for us. Okay, so first we're going to go from the tip of the arrow straight in horizontally. It's going to bend so that it is diverged out or spreads out. So what angle is that going to be? Well, we're going to have to use the focal point on this side to get that angle. So I'm going to draw it this way, but these are actually, this part is extrapolated, right? Because it's really going to be spreading out. So the actual light ray is going to come in horizontally and then spread out. But if we draw it back towards the focal point on the same side, that's the extrapolated light ray, but that will still be how we're going to get that measurement at exactly what angle it is. It'll be back towards the focal point on the same side. Now the next ray is just going to be exactly opposite of this. We're going to act like we're going through the focal point on the far side, except that when we get to the lens, we're actually going to draw it out horizontally. So what I'm going to do is erase this. I just needed it on the computer because I wasn't going to be able to aim correctly. So we draw it as if we're going through the focal point on the far side, but then it comes out straight horizontally. And then we're going to have to extrapolate that one backwards or draw it on the same side that we came from. It's not really reflected. It goes through. So we'll make that one dotted. And then the last one, just like the converging lens, it's going to go through the center. So from here through the center of the lens. And a little hard to see. Whoops, that's not the one I meant to change. But this dotted one and this dotted one, and then this one comes through all to right here. So in this case, it's on the same side. And remember, all these lines are dotted because they don't actually reflect. They should go through. But we extrapolated backwards to get the line. So these are from extrapolated lines. In other words, it's going to be a virtual image. It is upright. And it's smaller than our original one, so it's reduced. Okay, so hopefully the thoughts of how it actually goes through will help you do your ray tracing from here on out.